Hello, welcome to our channel for rprogramming and statistics. In this video, we will talk about polynomial regression with R. So we know linear regression is just a model to depict the relationship between dependent variable y and explanatory variable or independent variable x using a linear model. So here we call it is linear because the parameter beta 0 and beta 1 multiplied with x. They all are in linear type. And when the independent variable is only one variable, so this is called simple linear regression. And this line is the linear regression line, also called the fitted line, because it models the mean value for given x for the y value. So this is the mean value for the given x of the y value on this point. And the real observation is y value not exactly on this line. But this line is the best estimated line with this parameter beta 0 for the intercept and the slope parameter for the beta 1. And sometimes, in addition to variable x, for example, you may also want to add x power, so second power of x, or say quadratic term, to improve the model fit, because this linear line may not fit the observations best. Maybe the value for the observations has a band, so both sides up this line and the middle part under this line. So in this case, you may need to add a quadratic term in the model. So this kind of model is called polynomial because it also has one independent variable, but we use the second power in addition to the first power of this variable. So here, weight is the dependent variable y, height is independent variable x. In R, we also needed to add height. This color 2 means the second power of height. We add I outside of the parentheses because in R, I treats the contents with the parentheses as an R expression. What this means? So I means inside of this parentheses, we exactly use this expression. So here, because we want to use the second power of height in model as an explanatory variable, so we just use I of this expression. Because the color operates in R has a special meaning in formulas that combines all the integration between different variables. So if you do not add I here, just use height color 2, it is not exactly as what you want to be. Because color mostly used for several variables and for the integration term, for example, xy, xz, and yz. So this is kind of expression we will use in the later videos for other modules. So now we will show how to implement this module in RStudio. So quite simple. We will use the data woman. Woman data has a variable height and weight. We want to estimate the weight as a y variable, dependent variable, or say the response variable, and height as the independent variable. Here we add the second power of height also in the model. So we just use fit equals LM. LM is for the linear regression model. So LM, this function inside is a weight with a tilde symbol, which means the left side is the y variable, is the response or dependent variable. Right side, there are two terms. The first term is height, second term is height squared. Then we use data, which means data frame is a woman. This variable belongs to this data frame. We just run and the result will be assigned to an object called fit2. Next, we will use this fit2 and use the summary function. We show the result information. So there are quite a lot of information in this object called fit2. So first show the regression model's function LM, which we have run this statement. Then the residual term. Residual term is the difference between the real observations and the point on the fitted line. So residual show minimum value, minimum residual and maximum residual, and median, first quantile, third quantile for all the residuals. Then show the coefficients from the model estimation. So intercept, height, and I height, this is height square. So these three parameters. They estimate the point value and a standard error and a t-value. T-value equals the division of these two parts. And the p-value for this t-value. So all the p-value very close to 0. They are with 3 star, which means they're very close to 0 and they all significant. So which means these three parameters, these three items, significant and needed to include it in the model. And the residual standard error, this is for the residual term. There also a standard error. And the multiple R squared, which means the dependent variables variation has been explained by the model by the odd inclusion of odd explanatory variables about 0.9095 and adjusted R squared also very close. But this term is a little different from this term because this is things about the estimation of the parameter, so made some adjustment. But anyway, these two are very close. And F statistic also say the model explanation has a statistic. This statistic follows a TF distribution with 212 degrees of freedom and with a p-value almost 0. So this means also significant. The model is significant from these two independent variables explanation to the response variable. So next we can plot the relationship. First, we plot the sample data from these two variables for scatter plot. Then we add a line. Here the x is also the height. Y is the for fitted value. Fitted value is the line of this linear regression. We zoom. You can see the fitted line and the real, this point is the real observations. They both matches very well. You can see this line has a little bend in the words. Has bent a little underwards and they matched very well because we add a second power term in the model. Just note that although we add second power in the model, this is also linear regression model because the parameter, both the parameter beta 0, intercept beta 1, beta 2 here, they also has a linear term because this parameter just multiplied with the independent variable. So if we say we have the parameter in the power or in the division, so this is not linear module. So this is also linear module. Thanks for watching.